Most people look at the walls around them and never think about what's inside. But behind the paint, behind the decorations, every home, office, school, and skyscraper is built on one material: drywall. And the scale is unbelievable. Over 34 billion square feet produced every single year. Today, you're going inside the massive high-speed world of gypsum drywall factories, where mountains of raw mineral are crushed, cooked, transformed, and turned into endless sheets that shape modern buildings. Before we start, hit subscribe so you never miss how everyday materials are actually created. The entire journey starts deep in the earth. Gypsum is a soft white mineral, calcium sulfate dihydrate. Mining companies extract it in huge open-pit quarries where giant excavators slice out layers of rock. These blocks are hauled away on heavy trucks and delivered to processing plants. Once the gypsum reaches the factory, the transformation begins instantly. The raw mineral is dumped into massive crushers that pulverize the rock into small chunks. These chunks then pass through secondary mills, where they're ground into fine powder, the kind that feels like soft dust on your hands. But the gypsum powder can't be used in drywall yet. It still contains natural moisture and needs a complete chemical change. That change happens in a massive industrial oven called a calciner. The powder enters at one side and moves slowly through extremely hot chambers. The heat, around 150 to 180 degrees Celsius, forces the gypsum to release water molecules. This turns the mineral into calcium sulfate hemihydrate, known as plaster of Paris. This chemical transformation is the key to drywall. It allows the material to mix with water later and harden again into a strong, solid panel. When the calcined gypsum exits the oven, huge pipes blow the powder into storage silos. From here, the plant automatically measures exact quantities to prepare the drywall core mixture. This formula is more than just gypsum. Factories add small amounts of fibers, foaming agents, starch, and special performance additives depending on the type of board: fire-resistant, moisture-resistant, lightweight, or high-strength. These ingredients are pumped into a high-speed mixer where water is added. In seconds, a smooth, creamy gypsum slurry forms. This slurry is the heart of drywall, but a drywall sheet needs structure, and that structure comes from paper. Not just ordinary paper, but thick industrial-grade liner paper, produced specifically for gypsum boards. Two long rolls of paper are unwound onto a continuous conveyor. The bottom sheet runs flat while the top sheet waits above. The slurry is poured directly onto the bottom paper in a perfect, even layer. As the conveyor moves, the mixture spreads out smoothly. Then the top paper drops down, sealing the slurry inside and forming a long drywall sandwich. What happens next is pure engineering. The conveyor moves through a forming section where precise rollers set the thickness of the drywall. At this stage, the board is still soft and flexible. You could bend it with your hands, but the chemical reaction inside, the rehydration of gypsum, has already started. This process hardens the slurry between the paper layers and binds everything together. Factories must control temperature, moisture, and conveyor speed perfectly to ensure the board cures at the right rate. As the material moves forward, it forms a continuous sheet hundreds of feet long. Automated knives slash the moving sheet into exact panel sizes, usually 4 feet by 8 feet, though factories can cut much larger lengths for commercial construction. The moment the boards are cut, they're still warm, damp, and fragile. Workers can't stack them yet, and forklifts can't move them. They must pass through a long heated drying chamber called a kiln. This kiln is enormous, sometimes longer than a football field, and divided into temperature-controlled zones. Dry air circulates above and below the boards, evaporating the final moisture without damaging the paper. The boards move slowly through the kiln for nearly an hour, hardening into the strong, solid panels that construction workers use every day. By the time they exit, the drywall is firm, flat, and fully cured. After the kiln, the panels travel through inspection lines. Precision scanners check thickness, density, straightness, edge quality, and surface condition. Any sheet that doesn't meet factory standards is rejected and sent back for recycling. Drywall plants recycle almost all their waste. Rejected boards get crushed, separated from the paper, and sent straight back into the gypsum mixer. The perfect boards continue to trimming stations. Machines cut clean edges, ensuring every panel lines up seamlessly during installation. Labels and markings are printed directly onto the paper, so builders know the board type, batch number, and quality ratings. Finally, robotic stackers lift panels into bundles and wrap them for shipping. Forklifts move the stacks onto trucks heading to construction sites, hardware stores, or distributors. From raw rock in the ground to finished panels on the road takes only a few hours in a fully optimized plant. The scale of this process is massive. With billions of square feet produced every year, factories must operate at incredible speed. Some production lines run non-stop, 24 hours a day, turning out a new sheet every few seconds. Sensors monitor everything: paper tension, slurry viscosity, conveyor speed, kiln temperature, and chemical reaction rates. One tiny error can affect the entire line, so automation is essential. Energy efficiency is also critical. Kilns consume enormous power, so factories recycle heat, optimize airflow, and carefully control combustion. The calciner, which transforms raw gypsum into usable plaster, is another major energy user. Modern calciners are engineered for maximum efficiency, reducing fuel consumption and lowering emissions while keeping the reaction precise. But one of the most impressive parts of the system is how recyclable drywall is. Even though drywall is made fresh from processed gypsum, many factories use recycled gypsum sourced from construction waste or manufacturing leftovers. After crushing old boards and separating the paper fibers, the clean gypsum can be calcined again and reintegrated into new panels. This reduces mining, conserves resources, and lowers environmental impact. Drywall also plays a huge role in building safety. Fire-resistant boards include special additives like glass fibers or additional water content that slows heat transfer. Moisture-resistant boards use treated paper and chemicals that prevent mold. Soundproof drywall incorporates extra layers and denser formulations. All these variations are produced on the same high-speed lines by adjusting the formula inside the mixer. The result is a product so universal that every room you've ever been in is shaped by it. Offices, apartments, malls, studios, hotels, almost every interior wall, ceiling, and partition is made from these sheets. Drywall is lightweight, fast to install, and easy to finish with paint or texture. Its consistency has allowed modern construction to become faster and more affordable. Before this video continues, hit subscribe again if you want more behind-the-scenes looks at industrial systems powering modern life. Your support helps the channel grow and keeps these deep, focused videos coming with no off-topic filler. Now that you've seen how drywall is created, it's clear why the production lines never stop. The demand for new buildings, remodeling, and infrastructure keeps rising, and gypsum factories must keep up. From giant mines to precision mixers to kilns longer than entire buildings, the entire system is a perfect blend of chemistry, engineering, and non-stop manufacturing momentum. The next time you're in a room, look at the walls around you. They seem simple, but behind that simplicity lies an enormous industrial process. Millions of tons of rock crushed into powder, cooked into plaster, spread into sheets, dried, trimmed, and shipped. Also, walls can be built quickly and safely. And that's how drywall is made from gypsum inside massive production lines, producing more than 34 billion square feet every single year.